Hello friends, welcome to BISP Solutions. Myself Ashwin, and BISP Solutions is a tech company that provides technological solutions across the world. Now in this, what we are going to see, multi-layer artificial neural network on MNIST. Now exactly what is this MNIST, we will see it later. So now let me show you one thing that you might all have seen. Today is an interesting topic. So you might all have seen that on the traffic signal there are AI enabled cameras. Now exactly what these AI enabled cameras are, they are capable in reading the number plates, right, and also capable in determining the speed of the car. So what happens whenever a person is exceeding the limited given speed, in that case the camera will immediately take the image, and that image will be processed, and then based on that the accurate number of that car is derived from the database, and then immediately a challan or a bill receipt or a penalty receipt, anything, it is generated and it is sent directly on the email and by post to that particular person. So how it is done? So this is done with the help of multi-layer artificial neural network, right? And after this, if you see, second thing, let me show you this. Now this artificial neural network, what it does, first of all, let me give you the full form. Let me show you the full form of this. MNIST stands for Modified National Institute of Standards and Technology, right? So this institute, what it has done, it has taken some data and their levels. Let's take 0 to 9, right? 0 to 9. Now see, in worst case, suppose if a person is having very bad handwriting, right? So either he will write one like this, right? Let me increase this, zoom in, right? Okay, just a second. Let me, now it is okay, right? In worst case, if a person can write 2 like this, or he can write 2 in this way, so all the possible way of writing, someone write 1 like this also, and someone write 1, is all are possible. One a person can write. Similarly, if you see here, if you go down, let's go down here, see 7 can be written like this also. In some countries 7 is written like this and 7 is written like this also. So they have taken all the possible way of write handwritten 0 to 9, how a person can write. Some people write 9 like this, some people take 9 like this. So all possible ways. Some people write 8 like this, right? And after that, based on that, what happens, based on that, this neural network, it recognize out of this, which of CC here 0 to 9. Now this will be scanned and it will be fed to the machine, and that machine, based on its internal calculation and the algorithm, it recognize exactly what it is, 0 to 9, right? So that's why it is a classification, right? Now let's see this here, multi-layer artificial neural network on MNIST. MNIST means that we have seen Modified National Institute of Standards and Technology, and design small square 28 by 28 pixel grayscale images. Now see what they have taken here. We are taking an example of 0 to 9. Similarly, take the example of A to Z alphabet, because see, every car plate number, the style of number, the font size, the font style might be different, right? Let me take an example here. Let me show you like this. Suppose in some number plate, person can write A like this, right? In some like this also, A can be written like this also. Similarly, A can be written like this also, right? Then A can be written like this also, right? So in this way, different styles, different techniques, right? So what here we have done, we have taken a database of this MNIST, and among from that we have feed some data, and that recognized the exact number, right? So I will explain you with practical also. So let's start with this PPT first. Now see, multilayer perceptron, right? An MLP, multilayer perceptron, is a type of feed forward artificial neural network with multiple layer. Now here multiple layer means for example, in our last 2 sessions we have discussed that multi-layer, that means there are some hidden layers. I have also in my previous videos I have given you one example also. Suppose if I was asked to take the interview of 10 candidates, they all will reply correctly, no doubt. Now once they have replied correctly, that does not mean that all the 10 do. I will put one more hurdle. I will check their background, I will check their communication skills, right? Then again, out of those 10, 5 are rejected, 5 are selected. English is good. Then again one more, I will put one more hurdle. Okay, I will ask them about their previous background, exactly where they have worked. On the basis of that, I will try to identify their attitude, and in this way, after these 2 filtration process, I will get one candidate that will run along with the company. So in this way, these are called hidden layers, right? Same thing the machine does. Machine also do the same thing. It puts some hidden layer between the input and the output, and based on that it gives you only one output, right? For example, look at this. First we will go through this. An MLP is a type, just make it larger. Yes, an MLP is a type of feed forward artificial neural network with multiple layers, including an input layer, one or more hidden layer, and an output layer, right? Each layer is fully connected to next. Similarly, that's correct, because in my interview process also, one filtration process is connected to next process, right? Now let's come next. Now see here, MNIST stands for Modified National Institute of Standards and Technology, and is a database of 60,000 small square 28 by 28 pixel grayscale image. MNIST handwritten digits dataset is the most used in learning image recognition. See, as I explained you earlier also, many times on a car the number plate might be written by handwritten also. So they have taken all possible images how a person can write, and in case of very bad handwriting also they have taken all type of images, and then they feed to the machine, and then machine recognize. And here also training and testing procedure is used. Okay, so let's move forward. Now look at this. I am having a flat image. It is 8 written here, right? Now here you can see 28 by 28 pixel. Pixel is the very smallest unit of an image, right? So 28 by 28 pixel, height 28 pixel, and width the 28 pixel. Now if you see here, this is a straight line of 784. 28 multiplied by 28, that is 784, comma 1 means it's a grayscale image, right? It's not a colored image. Now between these two are the weight update, right? Now these are the hidden layers. After that it works on output layer, that is only 10 pixels will be there based on those. After that, cross entropy loss, this is an algorithm, or this is a function that is used here, right? And then with the help of this back propagation, that means every time, see in the training what happens, every time we repeats the same process, right? Just like an example, as we say, a child, he suppose if he is learning how to write the alphabets, right? We ask him do the same thing again and again, and finally his handwriting becomes good, right? So same thing is here. We run the epochs, we run the repetition for training purpose again and again, and finally after the training the test is done, and then you see the final output, right? Okay, so let's come to the practical part. Right now, see here, I have already created one, but we have, for our convenience, we will do one more thing. IPineUp file, right? So let's come here, IPineUp file, that is artificial ANN and MNIST, right? Let me rename this here. Let's click on this ANN MNIST, right? Let's go. Right, I will rename it again. Okay, now for this purpose, what happened, we have to first take the libraries, some very initial important necessary libraries, right? So I have already created one text file, and I will just show you in front of you. Suppose just a second, now it is okay. Now see here I will, now what is this exactly? See, import Torch. Torch is the very topmost library. NN is used, and that is NN stands for neural network. Optim means optimization. See, process is almost the same. First the input is taken, then it is converted into tensors, then optimization, then neural networks created, and repetitions, epochs are running, and then okay, transform means transforms the data we have to transform and fit inside the train test. After that, data sets, right? Now here we are taking the data sets, as we can see here. See here, this is the called the data sets. Here we are having the complete set of 0 to 9, right? All type of size, all type of style of writing, right? So here we take the data sets, then data loader, after that PLT for matplotlib for plotting the data, numpy means the library, and PIL imports the image, right? PIL import library. Okay, now I will hit the enter button. Now we have to wait for a few seconds, 2 or 3 seconds. Because importing library, it takes a little time, right? After that, now it is uploaded. Okay, now what I'm going to see, just a second, then I will import here. Let's come, okay, we come here. Now see here, define MLP, right? Multilayer perceptor. Now we are going to define this function, that is MLP function, and here what we take, 28 by 28 is the fix, that is the input image, and first fully connected layer, that we take the 512. Then in second layer, the output is output becomes the input for this, right? So this is the first layer, this is the second layer, right? And output is 10. Now if you see here, if you go look at this, where is that? Yes, here it is, 28 784. Then data is broken, and here you will see 10 by 10 comma 1. So same thing is here, 10 comma 1, right? So 10 classes for digits 0 to 9, right? Now ReLU function, activation function, right? The activation function, what it does, it will not take all the zeros values, right? Then you'll see the forward function, right? It flattens the image, and then it runs the ReLU function, output probabilities. I'm hitting the enter button. Now let's see next, what next. Here let's take this. Yes, now see, load MNIST data set. Now see, we want that our machine should be able to detect the handwriting or handwritten numbers, digits. So we need to download, or we need to install these images also, data set, what we say data set, right? So just I'm hitting the enter button, and let's see, load MNIST dataset with transformations. Now what we have done, first of all we transform the data, and we have converted the transforms into two tensor and then the normalize. Okay, now train dataset, test dataset, train loader and the test loader, right? It is now running, right? Now it is pulled here. Now what I will do here, I will initialize, right? Now see here, device torch.device CUDA CPU, right? It is, just imagine like work on a PHP or any other language on local host. When you are working on local computer, the database you write as local host database, but when it is uploaded into the the server, if you talk about the website, so what will change in settings file, right? So it is same as that. After that, because our and here the Atom optimizer is used. Now let's hit the enter button, and now just a second. Okay, now what will happen here, if I enter here and then if I enter here, okay, now what next is, here you will see, now since I have already executed this earlier also before this session, so you can see here, load MNIST dataset with transformations. So these are the loading output of how they are loaded. Look at this, because before this session I have already done this. So look at this, whenever you will hit the enter button, it already takes 5 to 6 seconds to do all these things. Then we come here, initialize model, right? After that we train the model. Now how we train the model? Now see here, number of epochs is 5, that means the repetition. Now we are repeating the repetitions. After that you will see here, it is still running, right? So loss, backward, and then the optimizer and everything is running here. So we need to wait for the results, right? So guys, initially we have taken the image, then we have converted into tensors, then we have loaded, look at this, we have loaded the MNIST data set, correct? And then we have given the parameters and the data, and then we have to take the epochs. That means for the hardly 5 repetitions that we are running, but they are taking time. So it's a big library, and now it is running. Just we need to wait for 2-3 seconds more. Yeah, look at this, epoch 1/5, the whatever the loss, that loss means the difference between the original and the predicted value. So if we have written here 5, then also it is taking little time, right? So if we take more time, so now let's one more time we need to wait. Here if you see, I have already executed this. So what happened here, this epochs run like this and it shows the loss, right? So same thing will happen here. We need to wait. So this is the standard process, and till it is running, let's discuss some scenarios in which this mechanism is used. Number one is detecting which car is running fast, right? Because in that case it will immediately check the image. Secondly, on the highway also, one more scenario is there. Suppose we are having 20 to 50 old books, but they are very good, so we can make the digital copy of those books also. We can make the digital copy of those books. How we will make the digital copy of those books? Definitely, whatever the font is, it will recognize the alphabet and it will convert it into the digital image, and then it will be able to write in PDF files, right? So there is one more, the digitization of the handwritten books, or the digitization of the printed books in future, right? Because suppose if the book is printed in 1950, now the condition of that book is not that much good, so we can scan all the characters and alphabets of those books, and then we will convert it into digital image, digital handwritten, right? Now slowly we come up to 1, 2, 3 and 4. Let's wait for few more seconds. So these are the second condition. Third we take for example, if you want to convert a complete book into the PDF file, we are having only one copy of that book, so in that case also this technique is used, right? After that, what happens here, let me show you here only. This 5 times epochs is running, then we will evaluate the model, right? So how we will evaluate the model? We use techniques, torch.no gradient, right? Image, we are putting the image here, then we will predict a torch.max output, and then this is the standard. We don't need to do anything in this, and it will show how much capable it is. I will show you that how much capable it is. Let's wait. Yeah, 4 also is done, and let's wait few more seconds. So now after that, what will happen? Predict image. Now it will look something like this. Suppose I have written 7 on a page, and then I will feed this image to the machine, so it will automatically and accurately it will check that which number is inserted, right? So this machine, this mechanism is capable for handwritten documents, or we can say whatever handwritten numbers. Right now we are talking about the numbers. So handwritten numbers on a page, it can easily identify, right? It can easily recognize. So that's what today's our session is. Let's wait for few more seconds. It will be completed soon, and once it is done, now see, we have taken only 5 epochs, that is why it is good. Now it is done, right? Now it is done. Okay, now what will happen here? Now it is done. Now what? Evaluate the model. Now we are going to evaluate the model. So what we are doing here, evaluate. Now I am hitting the enter button. So what we have done, evaluate the model means exactly model eval and correct equal to total. Now this is a standard process. Now it has given the accuracy of 97%, right? So 97%. Now what next? Let's see this function. 97, we are sure now that it is capable in reading the image, and it is 97% perfect. So what we have done, we have taken one handwritten image and we have inserted here, and now model dot evaluation and then image path, right? Convert image to grayscale, right? And then resize it into 28 by 28 pixel, and then it will in the normalize process, right? Then in this way, after doing all these things, let's hit the enter button. Now return predicted item. Now one more thing is there, we have to show. Now we have to show the data. So here we have already written grayscale for I equal to range 5, that means 5 epochs, so 5 iterations we have done, right? Here it is saying that image CMap gray, that means it's a grayscale image, right? After that axis is on, keep axis for better visibility, and then I will hit the enter button. Now see here what enter button will do. Now see 72104, actually predicted image is 7 actual, but image is also 7 only. Similarly you can see here actual image is 2 and the predicted is also 2, actual 1, predicted 1, and then actual 0, predicted 4. Clear? And today I have shown you exactly where the problem is and what is the solution for that. The problem is that on highway road most of the people, they drive a car very roughly beyond the limit, like 90 kilometers per hour, 100 kilometers per hour, and after that the particular car, and if it is exceeding the speed, then it immediately take the image of that car, and out of that image, now see, when you are taking image of a car, so definitely whole car will also be taken in that image, and a very small size nameplate will be captured, and if you zoom that image of that particular car and focus it on to the nameplate, so what you will, right? So that is why, keeping this thing in mind, we have taken all the possible numbers, right? So all the possible numbers we have taken, numbers are 0 to 9, but all the possible way of writing. Look at this, if you see, this is very different here. If you see here 5, how people write 5 in their different style, but up to a certain range only. For nobody will write 5 like this, right? You can see here 5 can be like this, 5 can be like this, 5 can be like this, 5 cannot be like this, right? This is S, right? This is not 5. So people write the alphabet or in their own way, right? So that is why, if you see here, now see, so that is why it recognizes the number, and today's recognition of the number, right? Recognition of the handwritten numbers or any style, right? The numbers written in any style, whether it could be handwritten, where the pen by using the different fonts. The this library, Torch library, is capable in detecting all these things, right? So let's have a quick recap first. First of all, our target is to recognize the handwritten alphabetic values, numeric values, right? 0 to 9, and in a different ways how a person can write, right? After that, what we have done, define the MLP, multi-layer perceptron model. We have defined this MLP model. Then what we will do, we will write here forward, then we will load the MNIST data set. Here the data set is written here, right? So we have taken the data set. Now let me show you the data set will it will be written in the back end, and it will be used in the back end only. So transform.compose, transform.toTensor, and transform normalize, it is done. Then train data set, MNIST root equal to data, and here you will see and shuffle data loader, train data set, and test data set. See, training might shuffle, but test data, it should not shuffle, right? So that's why we have taken here false. After that, initialize model, loss function, and optimizer. So device equal to torch.device, and if the device is changed, then we have to run this CPU and CUDA because of device change. Then model equal to MLP dot to device. Then the criteria NN equal to cross entropy function for classification, right? After that, optimizer optim dot adam and administrator, and then the model dot parameters, right? After that, we have to train the model. Now training model is same as previous processes, right? So reset gradient and then forward pass, then the compute loss, everything back proposition, right? And optimizer dot step update weights, and finally we get this epochs values, that is the losses values, and then model dot evaluation. We have to run this, and basis on this we get the accuracy, that is 95%, right? After that, definition is there, predict image. Now we are putting the information of real image, right? And then if you see here, this plotting, after this plotting the image, it becomes like this, predict 100% perfect. So this was all about the ANN MNIST